give you until tomorrow to do that. I hope that over the weekend you can start working on, as we're gonna start talking about today, start looking what you needed for your finish. As far as the recursive functions, you don't need to print the intermediate steps. You can, but you don't need it to. It's up to you. Well, the question on the timer, what happened is that you needed to probably do more iterations, loop it more times, because if you do just one or a few, you're not gonna see it. Make it, put it more time on that. Maybe try 1,000 times just to see what you get. If you start seeing a time there, then adjust. Maybe 1,000 is too much, make it a little lower. You just do a bunch of times. So let me do something here. Let me change it now before I forget. Yeah, if you just see 0 microseconds because you needed more time, computer is too fast and you are not having enough time to run that. Just do it more times. All right, I change the date to tomorrow. Yeah, I'm not sure how precise is the counter. I think nanoseconds, I don't think it can count that low. It's some limitations what the computer can do. Might be able to have some internal, but by the time it's delivered to the application, I don't think that the application can handle that so low timer. I'm sure there is some features that you can do internally from the computer to get lower timing, but for the purpose of our programming, we can't get that low. So the solution is do multiple times. What you do is just build a loop around the test and do 100 times, 1,000 times, and see how you get to a time that makes some sense. And you can just say this is the time for 1,000 iterations or 100 iterations. Yeah, so we were really not looking for a specific time that we might not be able to see. If you say, okay, give it 1,000 times for the iteration, give 1,000 times for the recursive, so you can compare those two. But we're not looking for the time for one iteration. Even if you are, you can divide that by 1,000, you can calculate for one, but you really don't need, you can display this is the time for X number, 100, 1,000, 800, 500, whatever. You just leave it there so we know that that time it was for X number of iterations. And whatever you do for the recursive, to be fair, you have to do for the iteration. So have those loops be the same. We just wanted to see it. Based on our understanding of this problem, what exactly happened? On the iteration, you have a simple loop that is going to be running a number of times. However, when you do a recursive, you have a bunch of function calls, which will require you to save the return address and everything. In theory, this would take a little more time. And that's what we will, if we will run it off, you will see that. In some cases, especially on the Fibonacci series, because each one number is from 2, if you put that number bigger, you're going to see a big difference comparing that with the iteration. Because you create so many function calls, if your number is big enough, let's say I want a Fibonacci series of 100, I told you not use that, it's too big. But if it's like 50, 40, you see there is a big difference between that and the one you implement through iteration. But that's probably the only case because you are exponentially growing the number of runs. If it's a one-to-one, the difference is very small between the two, if there is enough difference for us to see that. Anyway, it's a good experience for you to see what exactly happened when you run it and how much time is measured. Okay. So any other questions on the assignment 4? So I extend that to the 17, which is tomorrow. So give you a little more time to play around with some of those loops and the numbers and see the difference happen. But we should see a difference between those two, and we should see a number that we can count. We can see it. It doesn't matter if you're 1, even 100, you're probably not going to do it because computer, unless you have a really old computer that is slow, but most of the new computers, that's going to be a flash, especially for the factorial, which is very quick. All right. Let's talk about assignment 5. Next week, I'll show you a sample implementation for some pieces of that I have. I'll share with you. I just want to, on Monday, we'll be able to have all the information we needed because talking about inheritance, we will have everything we needed to implement that assignment. Just that we don't have up to today. So we're going to rely on the same structure we had for the movies that we created. In fact, I will use most of it. It's just a different input file is smaller. There's only 20 movies instead of 470. Okay, so what we get here. Like I said, this is a This is trying to reuse most of the stuff that we already done. Okay, so we're going to use this DVD movie list to get an introduction object-oriented programming. So we're going to write a program that allows a user to track their DVD. The DVD is user object-oriented program. We're going to use an input file that includes the following attributes. That's exactly the same as the other one. The title, so you can reuse most of the code. Anything that you're going to do for reading from the file will be the same thing. The difference is you're going to be inside of a class instead of being in a function. So what are the requirements? The user should be able to enter the name of the input file that contains the list of movies, and the output files will be the movie. The result of the output will be plays. We're going to create a stack class that will be used to store the movies. The class will be implemented using a linked list. Movies will be stored in a struct that we call DVD node. Okay, and the stack class will be defined using this struct. So here's the struct node. Struct DVD node. Those are all the fields we know, and we just create an X pointer here. This is exactly like the stack that we have implemented before. Here's the stack class definition that I'm giving to you, which is based on what we've done in class before. So you have a constructor and destructor, and then you have push, pop, is empty, pick, and size. So all those implementations, some way or the other, you have it because we already used that. And here, we don't know what's protect. Protect is a special privacy setting that has some advantage when you have inheritance. But imagine this will be a type of private, which we will discuss on Monday. And then we have a head node and a stack account. So one of the things that we can start looking at how we implement this. This is the class definition. And then the functions here, or the methods here, are the same functions you implement for your assignment, basically. What do you do with the size? You have the counter, you just return that. What do you do to pick? You just return a node that head is pointing to. Is empty, you just check if the head is empty. So all those things we already know how to implement. Hop and push, we already done that. So it will be a very simple implement because we use inheritance, which we know how to do on Monday. Then in here, I create a movie, ask for the file names, and just call two of the methods. Created, which is going to read from the file and put that on the stack, and then display that reads from the stack and put it on the output file. That's exactly what it does. So because we're using our object-oriented program, building all the capabilities inside of the object, main is nothing. Just say, go ahead and do it. And then let the objects to take care of everything. Like I said, we'll get more details on that next, on Monday. Okay, back here on our, any questions, any other questions you have, assignment 3, or assignment 4, or the lab we're working on, which is the object-oriented programming lab. Let me bring that up here since we're talking about that. Lab number 12. Any questions on lab 12? So we're supposed to here is create a animal class, which I provide you the class definition, and then have a menu that allows us to either change the age of the value or display the content of each one of the objects, which will be 3 static objects that we create. So I don't have anything new to go over anymore unless you have any questions. So if no questions, you're welcome to leave.
Damn, I'm clean in the bit, take a pit, flash on. Bitch, I'm headed for greatness, it's so close I can taste it. When they see me out in public, they so shot they be shaking. It's kinda hard to stay patient, it's too long I've been waiting. You already know, fuck them niggas that's hating. We gon' knock your screws loose, show you what them blues do. We gon' empty out your pockets and bitch take your shoes too. If you pop and want to smoke, he could be on the news too. We gon' pull up on the scene right there with the news crew. bust touch a mill, you know I will. Where you from? Jacksonville. Got this blunt and this couple with me. Don't need Dr. Phil. Had to get my mind right for a second. Strung out on pills. I done shook them demons off. Look at me now. I'm standing still. Huh? I've been wondering when are they gonna notice me? John, how you feeling? Fuck them rappers. They not cold as me. Child of God. He the only one who got control of me. But still down to get cracked. Don't make me show you ain't no hoe on me. Boy, I'm on they ass now. Time to take the trash out. I'm gonna smoke this motherfucking blunt until I pass out. Boy, I'm on they ass now. Time to take the trash out.